Hey you guys, today we want to learn about finding equal fractions. So we're working on concept 2 now. So we're moving into a new concept where we want to convert between rational numbers. And again, we want to find equal fractions. What are equivalent fractions? Well, that's our goal here. As I stated, I want to be able to find equal fractions that are smaller or larger than the original. So let's start with review. The first thing, and basically you learned this a few years ago, that the numerator is the top of a fraction and the denominator is the bottom of the fraction. So any number on the bottom we're going to call the denominator, and then number on top is called the numerator. Alright, let's start out with the definition. You want to write this down now. Equivalent fractions are two fractions that are different, but they are equal amount. They are the same amount. So if you look, this shows 1 shaded out of 2 parts. This shows 2 shaded out of 4 parts. But it's still, the green represents the same amount. So another way of writing a half is 2/4, because 2 is half of 4. So that's where we want to go here. How do I find these equivalent fractions that they look different, but they represent the same amount? First thing we got to be able to do, a couple of things we got to be able to do, is when we want to write equivalent fractions, we got to remember the identity property of multiplication. What is the identity property? And again, write this one down. What it represents is some number, or any number, times 1 will keep its identity, will stay the same number. So we want to know that if I take anything, a fraction, I take 42 and I times it by 1, I'll come up with that same number. So you will write it out. So if I take 3, times it by 1, you know this, that's 3. But what if I take 3/4 times 1? Well, I'm still going to get 3/4. So I kind of represented this identity in the video as a red, light colored red 1. So let's move on here. Another thing we want to look at now is we want to change this 1 into different fractions, and to show that 11 over 11 is still 1. 11 out of 11 pieces, you ate the whole thing. Here, 5, you ate 5 pieces out of 5 parts. It's still 1. It's the whole thing. And so with 7 out of 7 and 3 out of 3. Basically, any number over itself is going to give us 1. And that's identity. So now let's take that identity concept and bring it into equivalent fractions. So let's start with 2/3. All these fractions start with multiplication problems all start with 2/3. So if I take 2/3 times, and you see my little red 1 here, the identity, times 11 over 11. So if I multiply across now, take 2 times 11 and 3 times 11. When I multiply them, I'm going to get 22 over 33. Now, since 2/3 times 1 should still be equal to 2/3, and it is. 22 over 33 is still 2/3. It's still the same amount. So look at the next one here. Let's go to, if I take 2/3 times 5 over 5. So multiply across the top. 2 times 5 is 10, and 3 times 5 is 15. So 10/15ths is going to be the same amount shaded as 2 parts over 3. Let's check quick. What is that? Is that really true? So if I take 2 and I'm going to divide, that fraction bar means to divide, by 3, I get 6 repeating. 6, 6, 6, 6, 6. Now, if I take 10 divided by 15, what am I going to get? Is it going to be 6 repeating? Well, let's look here. So it equals Yes, it is going to be. And same with 22 over 33. Same with 2/3 times 7 over 7, because that's really 1. So 2 times 7, 14. 3 times 7 is 21. And then same here, 2/3 times 3 over 3. That's going to be 9/6. And again, it's the same as 2/3. So how do I find equal fractions if all of these are equal? Well, I just multiply the top and the bottom by the same number, because that's 1. All right, let's practice here. I picked some. Now let's pick some different fractions here to multiply by 3/8. So let's start with an easy. Let's multiply 3/8 times 2 over 2. So 3 times 2 is 6. 8 times 2 is 16. 6/16 and 3/8 are equivalent. They represent the same shaded amount. Let's keep going. Why? 2 over 2, let's try 5 over 5. Now it has to be the same number over itself. So 3 times 5, 15. And 8 times 5 is going to give you 40. And those two are the same. 3/8 is still the same shaded amount as 15/40. Just more cuts. All right. How about 100 over 100? Could I use 100 over 100? Sure. Is that equal to 1? Yep. So if I take 3 times 100, I get 300. And 8 times 100 is 800. Well, if I cut something up 800 pieces and I eat 300 of it, it's still the same as eating 3 out of 8. Now, do we like to use? No, we don't, because the numbers get pretty big. So we stay with 2 and 5, and 3 over 3 are pretty common. And again, multiplying the tops, and then multiply the bottoms. So I get 9 over 24. And that's, again, those are called equivalent fractions. What if I give you the bottom number? How do you find either the missing numerator or the missing denominator? So I want a fraction cut into 72. Is there a fraction that's equal to 7/9? Well, you kind of have to do a little division here to start out. And you say, okay, what is this? 2 over 2? 3 over 3? Well, let's look. How many times does 9 go into 72? Well, that's 8. If I take 9 times 8, that's 72. Well, if I multiply 8 on the bottom to keep identity, I have to multiply 8 on the top. And that's going to be 56. So 7/9 is equivalent to 56 over 72. Let's keep going. How about it going backwards? Well, again, what do I multiply 8 by to get 56? Well, that's easy. That's 7. And then what do I multiply by 7 to get 21? Well, 21 divided by 7, just like 56 divided by 7 is 8. This is going to be our 3/8 that we had on the other page. Let's keep going here. What about 4 7s? And I want a 20 on the top. Can I get a number down here? Sure. So what times? Yeah, you're ahead of me probably. 4 times 5 is 20. So if I multiply 5 on the top, I multiply 5 on the bottom, and I get 35. All right, one more. 2 times what? Gives you 18. Well, again, 2 times 9, that's 18. So identity, 9 over 9, which is really 1. 45 divided by 9. You got it. 2/5. So I can actually go from a big number down to a smaller number by dividing to get the smaller number. We'll look more about that in a little bit here. All right. Are these equivalent fractions? Are these equal? Because sometimes it doesn't work. Let's look. What times 7 gives you 28? Well, that's That's 4. So now I ask the question up here. Is 4 times 4, does that give me 12? No, that's 16. So are these equivalent fractions? No, they're not. So you can check to see if two fractions are equivalent just by seeing if the same number on the bottom, multiplying the bottom, or dividing on the bottom, and multiplying and dividing on the top, gives you these two numbers. So again, 10 to 30, that's easy. 10 times 3, well, is 3 times 3 21? Oh, no, it's 9. So are these equivalent? No. All right, how about this one? 6 times what? Well, that's easy. 6 times 8, that's 48. So now, is 5 times 8, is that 40? And yeah, it is. So these two are equivalent. And again, 9 times what? Well, 9 times 6. And 6 times 6, 36. And so a couple no's and a couple yeses. All right, let's keep moving here. All right, I want to answer the question, are there any numbers in between 1/3 and 2/3? Is there a fraction between 1/3 and 2/3? And a lot of kids are going to say, no, that's 1/3, the next one up is 2/3, but there are. There's a lot of them. If I find equivalent fractions, there are a lot, way more than we can even think of. So we want to use the concept that we just taught to make some bigger fraction or bigger number fractions that are equivalent to 1/3. So if you look at my example here, I'm going to use 8 and multiply both 1/3 and 2/3 by the identity 8 over 8. So 3 times 8, 24. 1 times 8 is 8. So 1/3 is really 8 24s. And 2/3, as you can see, is going to be 16 24s. So are there numbers between 8 24s and 16 24s? Yeah, there's a lot. There's 10 24s. There's 11 24s. There's 20 24s. So I still have equivalent. 1/3 is still 8 24s, and 2/3 is 16 24s. But I now can see that there are fractions going to be in between these right here. All right, a couple more concepts, then we'll be done. Can we make equal fractions that are smaller than the original one? Yeah, we can do that. I've already showed you. Well, let's say I have 12/16 and I want to go down. I want to get smaller. Well, what you're going to ask is, okay, what does go into 16 and 12? Well, does 2? Yeah, 2, they're both even. So I'm going to take out, instead of multiplying now, I'm going to divide top and bottom by the same number, 2 over 2. So if I cut 12 in half, I get 6. And I cut 16 in half, I get 8. Those are equivalent fractions. But I can do it again, because 2 actually goes into both of those. So and again, I'm going to take out 2. I'm going to take out, divide 2 out of both of these, and now I come up with 3/4. So this is called reducing or simplifying, when I keep knocking them down by taking out the same number out of top and bottom. Here's an easy one, 20 out of 80. Instead of building it up, let's take it down. So instead of multiplying, let's divide. So what goes into 20? Well, they both end in 0. So if you can see, instead of taking, yeah, I agree, 2 goes into them. But if I can get the biggest one right away, hey, that makes life a little easier. So 20 divided by 10, that's 2. 80 divided by 10, that's 8. Now if you look again, ask, is there a number? Are they both even? Yep. So I can take 2 out. So if I divide again like we did up above, take out a 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. All right, a couple more. What goes into 24 and 36? You're looking at it and you say, well, I know 4 is. So if I take out a 4, now 4 over 4 is the identity. I don't have it over the 1, but that's an identity. So 24 divided by 4, 6. 36 divided by 4, 9. Now, a lot of kids get stuck and they circle this and they think, yep, that's good. I reduced this all the way down. But I got to remind you, always got to remember 3. I'm going to take out 3 because 3 goes into both 6 and 9. And so when you do that, we're going to come up with 2 thirds. Now, 2 thirds is equivalent to 24 over 36. Same shaded amount. Okay. There's a shortcut I want to show you. If you look and I have zeros on the end, if I have 2 here and 2 here, it's kind of like dividing top and bottom by 100. So what is that shortcut? Well, if I divide both by 100, the quickest way is just to cross out the zeros. It's just like dividing by 100. So this is really going to give us 3, 6. But don't stop. Again, you got to look at it and say, okay, is there a number that goes into 3 and 6? Well, some kids can look and say, well, I know 3 is half of 6. Yep. And some of you can just jump right to a half and say, yep, that's going to be a half. Because look, it's 300 half of 600. Yep. All right. Last slide here. We want to look at what's going to happen in the next videos. I want to be able to find fractions that I can get to 10 or 100. And those two are really important numbers. If I can get my fraction to 10 or 100, it'll make life a lot easier. And we'll go into the next videos, but I want to talk about it now ahead of time here. So I want to look, does 4 go into 10? No. Does 4 go into 100? Well, I want to find an equivalent fraction that has a denominator of 100. Well, 4 times what gives me 100? Well, 4 times, 25, 4 quarters. So if I multiply 25 on the bottom, and now I multiply 25 on the top, I get equivalent fraction of 75 hundredths. Okay, how about 2/5? Does 5, just ask the question, does 5 go into 10? Oh yeah, yep, that's easy. How many times does 5? Times 2. So if I multiply 2 on the bottom and 2 on the top, I'm going to get equivalent fraction of 4/10. How about 24 over 60? Well, does 60 go to 100? No. Does 60 go to 10? Well, can I bring it down to 10? Well, what if I divide this by 6? Well, I get 10. Well, using what you learned here. Remember, we can divide both top and bottom by the same number. So sometimes I can bring it down. So 60 divided by 6 is 10. 24 divided by 6 is 4. Yep. 2/5 and 24/60, they're the same number. All right, 1/8. Can I get 8 to 10? Can I do that? Nope. How about 8 to 100? Nope. And sometimes this doesn't work with certain fractions. 8 doesn't go to 100. So sometimes it doesn't work. So there's another way to solve these problems that we'll look at in the next video. All right, let's review. It's getting long here. I can make equal fractions that are bigger by multiplying top and bottom by the same number, just like we talked about. And I can make equivalent or equal fractions that are smaller by dividing top and bottom by the same number. All right, that should wrap it up. Thanks.